So hello guys, welcome to my new video and myself Ashish Rival, and today I'm here again to explain my new project or say task with you, which is a part of my internship with Mentorness as a machine learning intern. So the task is about creating a machine learning model for prediction the aggregate ratings of a hotel. So a data set of a hotel was given to me by the company, and by the analysis of that data, I have to create or make a prediction model that can predict the rating of the hotel. So from the project, the objective of our project is to predict restaurant ratings that are based on the several features such as locations, cost for two cuisines, longitude, magnitude, and many more things are there. And accurate prediction of ratings that can be invaluable for restaurant owners and customers alike, and that will enabling them for making decision making better and improving customer satisfaction. So moving to the next slide. So basically next slide is about the data set description. The data set total have 9551 records and almost 21 attributes. So the first one attribute is the restaurant ID, and say second attribute is restaurant name, third is the country code, fourth one the city, fifth is the address, sixth is the locality, seventh is the locality verbose. So what is the difference between locality and locality verbose? So locality or neighborhood where the restaurant is located. This is the location where the restaurant is located. And the locality verbose, it is the detailed descriptions of the locality. So eighth is the longitude, the latitude. 11th is the average cost for two, means meal for two people. Average cost for two means average cost of a meal for two people. Currency has table booking or has online delivery now. So these are overall 21 attributes in the dataset was given. So moving to the next third slide. So slide is the first step of the creating a model. So the first step of creating a model is the data pre-processing. So the data pre-processing will ensure that our model works effectively. In the first step, we will clean and pre-process the data. This will include handling missing values, encoding the categorical variables like city and price range, and this is all by using the one hot encoding. And in the third step, we will scale the numerical values such as longitude, latitude, and average cost for the two using standard scale. So the first step is the checking missing values. There is a command for checking for summing up the null values, which is that df is null dot sum. So I have used this command for checking if there are any null values present or not. So we can see in the first first side there are restaurant ID, longitude, latitude, and in front of the attributes there are 00 was written. So this is the number of the missing values. Means there is no missing value in all of the attributes present. So then, if there are any null values present, I have used the drop and the method. So I especially use the aggregate rating in specific that column. The drop and the method I have used, it will drop the null values. If there are any null values, it will drop the complete rows. Then in the questions, I also use the fill NA method. Means if there are any null values present, then the null value is filled with unknown unknown string value. And then the fill NA again for the categorical attributes. If there is any null value present, then it will filled with the most repeating word. So again I have printed the null values. As we can see, there are 00 again, means there is no null value again. So in the second step, I have converted all the categorical values into numerical values. So this thing I have done with the help of label encoder. I have imported the label encoder into a object which is LE. And by the use of fit underscore transform function, I have transformed all of the categorical data into numerical data. Means has online table booking. So there only two options are there. Means has the yes or no. Means if the table booking, yes. If the table is not booking, then no. So then I have encoded the currency attribute also, in which the values are given in the Indian rupee. So by use of fit underscore transform, I will encode the currency into numerical values. Then I have used the pd.get dummies for the city, country code and price range values. Then in the third 3.3 step, I have normalized or scaled the numerical features. And why I'm doing so? As you can see in the question, there are 921, 1111, 16, 17. Means in a attribute there are small values present like 100, 200, and there is sudden a high value occur like 2000. And this small and big values together can bias the results. So in this situation, we will use the normalization and normalize the scale source in the attributes. So I will make a list of the numerical features, uh, means that have the numerical values like longitude, latitude, average cost for two, and the votes. So using the fit underscore transform function, I will scale all of the values of these attributes. So as we can see, the values of the longitude, latitude will converted into 1.37, 1.37, 1.37, 1.37, and minus 1.02. Okay, so moving to the next slide. So the next slide is about the area of the data. I mean, there is a distribution of the data was given. The distribution is about the aggregate ratings to the count. Means if the rating was given for, then how many times the rating was given for. This is the count plots. So the distribution of the aggregate rating reveals a bimodal pattern with a significant concentration of ratings at G, and that is indicating that there is another peak in the 3 to 4 rating range, and that is suggesting that a large portion of the data set falls within this moderate to high rating category, and the sparse presence of these ratings between 1 and 2 indicates that users are tend to either give a very low or relatively high ratings. Means the users either will give the very low ratings or either they will mark the high ratings. And this polarization in ratings could suggest that users are more likely to rate items that extremes or that the system might encourage such rating behaviors. So again on the next sheet, there is a scatter plot in between aggregate ratings and the votes. So the scatter plot it reveals that most entities receive a high aggregating rating above 4. Okay, and despite having a relatively low number of votes, it is suggesting that highly rated items often garner limited attention. Means the highly rated items gar, oftenly garns limited attention. Means there is a noticeable clustering of data points in the upper left corner, and that is indicating that while many items are rated favorably and they don't attract a large voting base, and the conversely, as the number of the votes increases, the distribution of ratings becomes more varied, with fewer entities that are attaining either very high or either very low rated ratings. And this pattern highlights a potential disparity in between the popularity and the perceived quality, where the items with fewer votes are often highly rated, and while those with the more votes show a broader range of the ratings. So so this is all about that scatter plot. Okay, so Moving to the next slide, this is about the model development. So I have opted the random forest regression and the linear regression both as our predictive model. So I have split the data into training and testing sets in the 80-20 ratio. Means the 80% of the data set was given as a training set and 20% is given as the testing set. So the model performance was evaluated by using of the metrics like mean absolute error MAE and the mean squared error MSE and the root mean squared error RMSE and R squared score also. So as you can see in the step number 6.1, I am splitting the data into first of all xy variables. So from the x I will drop the target column. Okay, and the target column I have fixed into the y variable. Then in the 6.2 figure, you can see uh, I am using the linear regression model, and by fitting the x train and the y train, I'm doing some predictions, and these are the values of the matrix and the values of the uh, evaluation matrix is MA, MAE, MSC, RMSC. We will talk about this in the next slide. And same in the random forest regression also. By fitting the random forest regression with a random state of 42, I also calculated the same MAE matrix, MSC matrix, and RMSC matrix. So this is the next slide, which is about the model evaluation. And both of the image shows a performance comparison of the two regression models. One is the linear regression model, and second is the random forest regression. So both of the models are trained on the same data set and with their performance evaluated using various metrics like MAE, mean squared error, and root mean squared error. So these are the values of from linear regression: MAE, MSC, RMSC, R square score. So we can see the negative R square score indicates a poor fit. Means it the model will fails to understand the understand the or say the model is failed to capture the relationship between the features and the target variables. And we can see the R square score in the random forest regression is 0.987, which is almost 0.99 and very close to the 1. So the random forest regression has significantly better performance with a near perfect R square score close to the 1 value. That is indicating a very strong fit and excellent predictive power. Then this is the last slide of the conclusions. Means the random forest regression outperforms the linear regression model by a wide margin across all evaluation metrics. The linear regression model's negative R-square score indicates that it fails to model the data effectively, and possibly it is due to the complexity of the relationship between the input features and the target variable. And the random forest regression's high R-square score and low error metrics suggest that it captures the underlying patterns in the data well and making it the superior model for the specific dataset. And this comparison highlights the importance of using more complex models like random forest for the datasets where linear relationship might not suffice, providing more accurate and reliable predictions. So this is all about the creating a machine learning model. And thank you for watching the video and connect with me for the latest projects and the videos.